All right, hello everyone, and welcome. Today we're going to look again at conditional probability. I want to talk about these tree diagrams. This is actually a pretty good example right here of what we'll be talking about. And just a quick review. Guys, independent events is when one event does not affect the other. Like tossing a coin. You toss a coin twice, even if you toss two coins at once. The outcome of one doesn't affect the other. And that's true with dice too, okay? But dependent events means that one does affect the other. The probability of one event is affected by the probability of some previous event. All right, as an example, we have marbles in a bag, 2 blue and 3 red marbles. What are the chances of getting a blue marble? Well, the chance is 2 out of 5, of course. You take one out. However, once one is out, the chances change for the second one of getting another blue marble. If the first selection we got was red, then the chance of a blue marble is 2 out of 4 for the second selection. But if we got a blue marble the first time, then the chance of a blue marble the second time is now only 1 out of 4. All right, because those events are dependent. So the chance of getting a blue marble the second time is different depending on what happened in the first event. All right, this is because we're removing marbles from the bag. Again, we talked about this, replacement. If we replace the marbles into the bag each time, then those are independent events. The chances don't change. All right, it's as if we start over again. But without replacement, we don't put the marbles back in. Those events start to become dependent. The probabilities change depending on what the events happened before it. As a tree diagram is a great way to look at this. All right, this shows our probabilities right here of getting a blue marble and a red marble the first time. And all the tree diagrams we'll work with will have like a binary, it's known as. It's one or the other. So if you add these two up right here, you get 5 out of 5. That's all the possibilities. All right, then we can go to the next step for the second selection. All right, the second selection, if the first selection was a blue marble, the chance of getting a blue one is now 1 out of 4. And the chance of getting a red one is now 3 out of 4. But if we selected a red one the first time, the chance of getting a blue marble the second time is now 2 out of 4. And the same with a red marble the second time, 2 out of 4. Because as you can see here, there are 4 marbles, 2 blue and 2 red. So we can use this to answer questions like this. And again, we've looked a little bit at this. What are the chances of drawing 2 blue marbles? All right, so you multiply the two events together. 2/5, you see this top? And 1/4, that's the 2 blue marbles right there. 2/5 times 1/4, simplified is 1/10, okay? Now I want you to focus on this second column right here. That's what's known as conditional probability. The chance of something happening when another dependent event has already happened ahead of it. It's happened before it. All right? This is conditional probability right here. All right? Remember, the answer here is if they both happen. That's the and. That's why we multiply them together. And there's lots of notations we use here. Some of this is review, but some of this is new at the bottom. Again, when we write something like this, the P with the A inside parentheses, that means the probability of event A. What's the probability that A happens? Again, if event A is get a marble first, then the probability is 2/5. And if event B is get a marble second, however, we have two choices for that. All right? It depends on what happened the first selection. So we have to say which one we want. So we write it like this. The probability of event B happening given that event A has already happened. We have that little line in the middle, all right? Straight up and down line. In other words, event A has already happened. Now what's the chance that event B happens? It's known as conditional probability. All right, so the conditional probability, again, is the 1/4 in this case. So the probability that A and B both happen is equal to the probability that A happens times the conditional probability, the probability that B happens given that A has already happened. That's what we do here, okay? Now we can solve this for the conditional probability by dividing both sides by the probability of A, which is what we do here to get the formula. All right, again, this first step, you just switching sides here. The A and B just moves to this side. And the multiplication moves to this side. And then just divide both sides by the probability of A. All right, this is what conditional probability is. The probability that B happens given that A has already happened is equal to the probability that they both happen divided by the probability that A happens. As an example, as if 70% of your friends like chocolate and 35% like chocolate and strawberry both. What percent of those who like chocolate also like strawberry? Again, we are limiting the original sample space to just the people who like chocolate. How many of them like strawberry? All right, so the and part goes on top. All right, that's the 0.35. And the probability of just the chocolate goes on the bottom. That's the 70%, that's the 0.7. Put in your calculator, you get 0.5 or 50%. All right. Half of your friends who like chocolate also like strawberry. All right, guys, that's it. Please complete the homework assessment in the purple folder. And thanks for watching. Remember, the test is coming up.